Good morning. So today's lesson is areas in the plane. We have kind of talked about this already. I have put this handout. It's really close to one that was up on the math website for areas in a plane. This one's just a bigger version a little bit, so hopefully it'll be better for you to see and follow along. But you can print out this blank one. It is going to be up there under our applications of integrals unit. So one thing, we have talked about integrals before, we have talked about area, and the type of things that we looked at were situations where it mattered if you were above or below the x-axis in terms of positive or negative area. So if I had a situation up here versus one down here, and I want to talk about area between my curve and the x-axis, that would be considered a positive area. That would be considered a negative area. So if I were going all the way from a lower limit to a higher limit, maybe they'd cancel out. This looks like the positive area would be bigger, so my net area would probably be positive. Had this thing kept going and done something like this, then more likely my net area would be a negative area. So what was important is the measuring line was what we talked about between the curve and the x-axis. So now we take a different plan. We're not using the x-axis as the other barrier line. So the idea is I could have a trig function here, and I could have a line. And somebody says, here's my limits, and I take that picture. So here's the x-axis. So what is the area between my curve, which is some type of a trig curve, and a line? Well, that would be positive. But even had that been drawn below the x-axis, so let's tip it upside down. Let's say this is still the x-axis, and I'm starting over here at A, and my upper limit is B, and so now I have this line y equals -3, and I have a trig function that's been translated down. This area is still going to be positive. It is a matter of what is the quantity between two curves. So yes, everything is existing down here below the x-axis, but when I figure out the area from here to here, it's going to be positive if I do it properly. So what we now really care about is being able to identify which was the higher function. This line right now is always higher than this line, so I would call this my high function, and this would be the trig function would be my low function. Had it been the way I originally drew it, and now these things are above the x-axis, the trig graph would be my higher function, and this would be my lower function, because we always want to set it up high minus low. So if we do that, I'm safe. How can you be safe? It's wonderful to have a graph. Then it is looking at you in the face, which is the higher function and which is the lower. So when I have a look at this scenario, here's the top function, continuous function called f of x. There's a lower function called g of x. I really don't care if this is sitting above or below the x-axis, but I can see f is higher. So if f and g are continuous with f greater than or touching, crossing, bouncing off g on this interval, closed interval AB, then how am I going to find the area between those curves? From where they first start, that area first starts, where it ends, and this idea only works if you start with the high function and then you minus the low function from it. So that's what makes a graph really, really good. So this would match my graph. If g were the higher one, I would have g of x minus f of x. So the problem comes where, what if I didn't give you a picture? What if you don't know what's going on? Well, you would incorporate absolute value, as you'll see in a couple of our examples, okay? So if I look over here, I have been given two functions. Now these kind of questions can be on a calculator part of an exam or a non-calculator part. If they're on a calculator part, you can graph them. You can use your Math 9, your definite integral key to find your areas. That becomes a very easy question. So they would be looking for, can you even set up the integral then? But the idea is here, that's just an exponential growth function, and that's the line called y equals x. Typically, for the time it would take you to draw this stuff by hand, it's worth the time to do it. So if I drew those two, this would be my y equals e to the x. This would be my y equals x. They're saying I'm going to start at x equals 0 and I'm going to go to 1. So that's the area I'm looking at. It's really easy to see the high function minus the low function. So it all starts at 0 and it goes to 1. Those were given in this case. And there's my high function. There's my low function. So if right now it was a calculator question, I go math 9 and let my calculator work this out for me. Chances are you're going to do it by hand. So you're going to integrate. So e to the x came from e to the x. Your x came from a half x squared. There's your limits. You're going to sub in. You're going to get an answer. So you can keep that as an exact answer. If you didn't have this picture, all right, and you did it backwards, how would you save then your answer so it'll be correct? If you had no picture to look at and you did this the wrong way, you did x minus e to the x, that's okay. You'll just absolute value. So everything else would have been the same. You would have had this inside here, but it would have been within absolute value. You would have had the wrong answer. This would have said 3/2 minus e, but when you absolute valued it, you will still get the right answer. But there's that sense of comfort if you can draw the graph. Okay. All right, going on to the third box. There's what that is referring to. If you don't know which one is greater, in other words, the higher, or sometimes they change. Graphs can cross. So a minute ago, something was the higher graph, and then after the point of intersection, it's the lower graph. That becomes an issue too. You might have to do some algebra. You might have to algebraically, analytically find where the functions meet. So here's just a really basic example. I've got y equals x squared, and I've got y equals x plus 2. That was very easy to draw the graph. That's why I did. But otherwise, what do I want to do? I want to find out where these two things meet. So it would have been x squared equals x plus 2. You move everything over to one side, and you factor. So you're going to have x is 2 and x is -1. So now you know where they meet. They meet at -1 and they meet at 2. So that immediately takes you to here. But now what's your question? Who's the high? Who's the low? I can see in this region, the higher graph was the line. The higher graph was y equals x plus 2. The lower was x squared. So it would make sense for me to put it in that order. There's that function minus the other entire function, and then dx, okay? And then I could solve this by hand and I would have my answer. If I screwed up and did it the wrong way, if I said x squared minus, and then of course you're going to make sure you use brackets, take that through, I'm going to save my possibility of getting a wrong answer by simply absolute valuing it within. And then you'll get the same thing. So that's what this is showing. If you have to do something by hand, you definitely have to know where the region begins and ends. If you can see high and low, that's less work for you. But simply if you're doing a calculator, there's a function minus the other function. If you don't know for sure which is low and high, maybe this was the right situation, just absolute value it. Okay, next one here. So again, you are given two parabolas, and you are asked to find the area enclosed by them. So they would a sketch would be very, very handy, or on your calculator. And then you need, they're not telling you where this starts and where this ends, all right? So you need to find where they meet. So this is the process here of finding where they meet. You put them equal to each other, and whenever you get 2 points really defines one region. So now I know they're meeting at 0 and 1. So they're meeting at 0 and 1. If I took a minute and drew y equals x squared, basic parabola, and if I factored this one and looked at it, I can see it's opening down. I can see the x-intercepts are 0 and 2. It wouldn't take me very long to draw that one. And here's where they're meeting. And then I can even see, right, which is the higher function and which is the lower function. In this region, the higher function is the parabola opening upside down. So that would be the second one that they gave me. So I can set everything up I can see it. I don't have to worry about absolute value signs. So I'm going from 0 to 1. There's 0 to 1. I've chosen to do it. There's that upside down parabola minus, there's the normal parabola. So this was the high, that was the low. Combine them for sure. If you can combine like terms, you get it down to here, you evaluate. This is obviously doing by hand. If you had this all wrong in terms of order, you would absolute value it. Your answer would have been negative 1/3 in absolute value signs, but you're still going to get positive 1/3. Okay, let's see if there's anything else I wanted to mention there. Don't think so. Okay, now, sorry. Again, I mentioned this. If it is a calculator question, then they know the Math 9 button is going to give you the value for the area. So they're going to be looking at how did you set things up? Were you aware of, did you include a diagram? Do you know which is the higher value? Do you have it in the right order? Did you account for that by putting absolute value signs on? As you're going through the book, they will also ask you to do some work with Riemann sums. So that's something from a previous unit, but that would be good to review as well. Okay, other things can happen. You can have more than 2 meeting spots. So this was a really good example. It looks pretty difficult just having a look at it. I would say as soon as they start giving you 3 diagrams, if you can draw it, awesome. This wasn't that bad. Basic parabola moved 1 down, a basic parabola moved 1 to the right, basic parabola moved 1 left. So by an accurate drawing, you can actually just find where they meet. It'll just all work nicely. Or do 2 at a time. Where do these guys meet? Where do these guys meet? You will get these answers. These 2 are meeting at -1. These 2 meet at 0. These 2 meet at 1. So this could be an awful lot of work. How are you going to do this? Well, you have to look at it in separate areas. The idea would be it's this function and this function involved when you're going from -1 to 0. We can see the higher function and we can see the lower function. So that was done here. From -1 to 0, there's the higher, there's the lower. Don't need to worry about absolute value signs. Then they continued on from 0 to 1, but now it's different functions. So they were put here in the right order. There's the higher, there's the lower. Now, what are your choices? You can expand this and get it smaller, or you can just integrate. You have to watch for K values. If this been a 2K right here, and as you're integrating, you could use substitution, but instead, as you were integrating, you're going to end up having this 1/2 plus 1, and had that been a 2 there, okay, let's say that was a 2x plus 1. Don't forget, you're undoing that 2. And you will find that happens quite a bit in the homework that you're being assigned. So if it's just an x or a theta, you're good. As soon as something else is with it and you're integrating, you have to undo that k. Now the textbook talks a lot about better approach would be using symmetry. So what does that mean? Okay, here's some pictures from your textbook. So what would you consider here as being symmetrical? Okay. So we're talking, it's going to be symmetrical about the y-axis and the x, about the y-axis, yes. So if I look at this, I could definitely say I'm going from this is page 380, -pi/3 to +pi/3. When I do set up my intervals, I'm going to have negative, for my a value to start substituting in. What is a much easier process is take half of it. What makes sense, take the positive half that starts at 0 and goes to pi/3 and say, I'm just going to double that area. Of course, you can't do it here. That wouldn't make sense. Top one wouldn't make sense. But here, these are identical. So don't go from -2 to +2 and get yourself into negatives. Say, I'm going to find the area from 0 to 2 and double it. Same thing here. I'm going to find the area from 0 to 1 and double it. Now, if that can be done. So having a graph is going to let you know, therefore, if it can be done. Something went. There we go. So you see this all over. So in your answer keys and everything, you're going to see, remember your answer keys are on the math website, where they'll go or use symmetry. That's a very smart short procedure to do, so they use it a lot. All right, and again, if you had all this backwards, then you would be forced all the time to be putting in absolute value signs for each section, like for this section on its own and then that one. Okay, we are almost done. Here's a situation. I'm just going to maybe move this up a bit. This is a situation where graphs can cross more than once. So let me just grab a piece of paper here. If I had, just a minute, I wanted to show you something there. There's all my paper. If you were supposed to consider an area, so I've got some kind of polynomial curve here, and I'm cutting it with a linear curve, and somehow I'm starting way over here, and at this spot right here. And I'm going to finish at this spot over here. And I'm supposed to find the area between these curves. Well, that would be there, that would be there. There's more there, there's more there. So at one point, the polynomial was the higher graph here, but then in this region, the line was the higher graph. And then in this region, the polynomial is. And then in this region, the line is. This becomes very important that you find those transition spots. So maybe from 0 to 1, that's something happening. From 1 to 4, like this for the x-axis, 0 to 1, something's high. But then 1 to 4, something else, it became the lower. And then from here to 7, and then from here to 8. These need to be taken account of when you're doing something by hand. If you're doing it on a calculator, oh, so easy. You'd say, I'm going from 0 to 8. Here was my polynomial. Here was my line. There. Calculator will do it all for you. It will change. It knows from what was the high function to what was the low function. Can't get easier than that. So you're not going to get too many of those questions. What you're going to get would be something like this. Okay? So they're given a parabola, a line, and two spots, probably a start and a finish. So if you can see this here, so we're going from -2 all the way to 5, but within there they start to cross. So you find out where they meet. You put them equal to each other and you come up with these values here. So look at all the values that you have. You know it's starting at x is -2, it's going all the way to 5, but then they also cross at -1 and 3. So those create new intervals. They go from -2 to -1, where the parabola was higher, then -1 to 3, where the line was higher, then 3 to 5, where the parabola was higher. There's going to be something very handy for you to use right here. And this is a step when you were finding out when they meet, where you moved everything to one side. So the long way of doing this is to section by section say, okay, high minus low, high minus low. So the parabola was higher here, minus the line, and that happened from -2 to 1. Then we're going to add on. From -1 to 3, the line was higher. So there's your high minus low. Then you're going to add on from 3 to 5. Now your parabola was higher. This and this and this are all this. They're the same thing. But sometimes it's in the wrong order because this showed we moved the line to this side. So this is what it looks like when we have parabola minus line. Had we moved everything to the other side, it's line minus parabola. If you're just going to go put absolute value signs on everything anyway, you don't care. You do have all those special limits. So what you could have done actually, instead of all this, is say, okay, I'm going from -2 to -1, and I'm just going to use this 2x squared minus 4x minus 6. To that I'm going to add, oh, now I'm going from -1 to 3, that same thing right there. You don't have to turn it around. And to that I'm going to add, going from 3 to 5, same old thing in there. all right, that will work for you. You will have taken all those areas, your absolute value would have given you positive answers for them, and then you throw them together. But of course, had you had a calculator, this is all you're doing. You're simply saying, I'm going right from -2 to 5. I don't care about the intersection points. And I said parabola minus line. You will get the same answer this way. Last thing, sometimes when you get intersection points, it is really dangerous to round. So make sure you know how to use the store feature. All right, and if you're doing this on a calculator, right, and you need some very interesting values here for your A and your B. So let's say you end up with something like, I don't know, we get an answer 1.23456789, and I really don't want to keep writing that. So I could press the store key, which is down here, and I'm going to store it under a letter. So your letters are all in green, or they're above all of these keys. So alpha would get you to that. So if I want to store that number as A, I'd go alpha A. Okay, so down the road, now I want to go -1 times alpha A. Well, to recall alpha A, you're going to press alpha A, and it recalled it for you. So you would enter that right within your Math 9 work. Okay, so that's the lesson. So there's a new outline. I kept the old outline, which was this one, on our Google Classroom. This was real minimal work. This was real minimal work. Because we're not having a quiz. We're not, after spring break, it was going to be all about volume, but we're leaving that. Probably, I'm thinking this week I will put this next lesson up, and otherwise we're going to take a break till after the exam, AP exam. So I redid what I think would be a better choice for you. These should go along with today's work. That would be your Math Excel work. This would be really good for the rest of areas in a plane. If I gave you a note there so you can read that on your own. One thing I do want to stress is make sure you are looking at the AP Central. They have this course at a glance. I always had it in my room, but it shows every unit and what is covered. Something in gray is not Calculus AB, it's Calculus BC. But you can get this not under the COVID warning, but this is under just you logging into the course. And it opens you up, whoops, into a 248 page document, but they do show you every unit by unit. And you know what? We've done everything. We don't do units 9 and 10, that's Calculus BC. We've really gotten to everything but these volumes. So if you want to see this, that's where it is. It's under the course and exam description, fall 2009. That's handy to see. Last thing. When you see some interesting stuff, and back in the last unit, never forget your Math 30 and all those trig identities, which were on a Math 30 formula sheet. There are lots of identities for cos 2x. That can be written as 2 cos squared minus 1. That can be written as 1 minus 2 sine x squared. That can be written as, I think it's cos squared minus sine squared. We don't like dealing with squares. This becomes so nice and easy for integrating. We recognize there's a k, but it's very nice to integrate something like that. So as, I think it was back on page 312, the textbook, when you were doing some work there, gave you a hint on what to do if you are stuck with maybe cos squared. And it wasn't so that you had to memorize that hint. You should know where that hint came from. So let's say you had to integrate this, all right? And they gave you a hint. Where this came from wasn't the idea it came from 1 minus sine squared. It's the idea it came from something that wasn't being squared. It had a connection to cos 2x. So you could say, all right, cos 2x is 2 cos squared x minus 1. So I'm looking for a replacement for this. So the next step would be to add that over. So cos 2x plus 1 is cos squared. And, sorry, then there's a 2 here. And then divide by 2, divide by 2. So you have a different replacement now for cos squared. You would have 1/2 cos 2x plus a half. There is now a replacement for cos squared. Why would that be preferable to this? This is really nice and easy to integrate. You could haul a half out of each of these if you want and take the half right outside if you want. But this in itself, to integrate, just recognize you have a k. So you would be going a half. You're going to undo that k. And then where did cos come from? Well, it came from sine. And then where did a half come from? It came from x. And then whatever your limits are, you would keep going that way. So anyway, you will see that here and there where they'll give you cos squareds and sine squareds. Those would be the identities that you want to use. Okay, so good luck. Hopefully the video was clear. You can get through that. I'll be calling if I haven't already spoken with some people here, see how you're doing. Besides this, again, your focus really should be watching for those AP updates. I gave you a link to their daily, looks like Calculus AB is at 2 o'clock, well, noon our time. Different lessons every day, so they're probably worth that 45 minutes to help you start reviewing. Look through those previous old free response questions, the answers are there, and really start preparing yourself. Miss you all, and I will talk to you soon. Bye-bye.